So let's start with this. The remind code, if you want to join my remind list, the remind code is at C4EBBEB. So if you want to put that in, I'm going to remind us of tests and quizzes that are coming up as they happen. So, Newton's second law says that if you are accelerating, there must be a net force acting. On the object. So, the mathematical statement is this. The left side says the sum of the forces, which is called the net force, is equal to the mass times acceleration. So I'll give you a second to copy. We'll work on that. Well, if you want notes, you're going to need to, yeah. It's okay if you don't do too well with the Greek letters. You'll get better at them as we go. This is the Greek letter sigma. And it means add up. So, like, you probably are familiar with fraternities and sororities in college, at least you've heard of them. They might be something like Phi Sigma Eta. Those are all Greek letters. And usually it comes from some particular word that gets associated. Like Mu Alpha Theta, our Math Honor Society, is math in Greek. Those are the three letters that spell math. Oh, yeah, sorry, not a good window. So, we use Greek when we sort of run out of letters in English. And we run out of letters in English sometimes in physics to measure all the things we want to measure. But this letter is the capital one that sort of looks like an E is sigma. It's a capital sigma. Capital S in Greek. And it means sum or add up. So mass times acceleration. And so when we have unbalanced forces, our object is going to accelerate. If I push harder in one direction than I push in the other, I've got an unbalanced force, so we're going to accelerate. So when we do that, we're going to add a little bit of math here to start with. So, what is the net force on a 3 kilogram cat that is accelerating at 4 meters per second squared? So when we ask for the net force, that's the extra amount. That's the extra amount that we have that's not balanced by the other things. So what is the net force on a cat that is accelerating at 4 meters per second squared? Well, our net force is mass times acceleration. So that would be 3 kilograms times 4 meters per second squared. So our force, our net force, would be 12 kilogram meters per second squared. Oops, sorry. I need to erase that up for you. It's pretty simple math here. I'm talking in my AP Physics 2 class about how physics, if the concepts are easy, then usually the math is hard. But if the concepts are hard, the math is usually easy, which is kind of weird. You'd think they'd be both hard together or both easy together. But it does seem to be that some of the harder math pieces end up being easy things to say. Kind of like if you're trying to explain why a number is even. Well, it's even. How do you explain that it's even? In one of my classes in college, I had to prove that 2 was even. And we were all looking at our teacher like, it is. How do you prove that? And I had to learn about the area of number theory, is what the class was about. So I had to learn how to deal with that. But that was weird because, like, 2 is even. It is even. It's like the first one. What do you mean that I have to prove this? But anyway, so force is mass times acceleration, and this is sort of the easy form of it. It will get a little bit more difficult. We don't know what forces are acting on the cat. We just know that since it's accelerating, there has to be some amount of unbalanced force. So somehow, the cat is either pushing on the ground hard enough so that it can accelerate forward, it's running away from something or running towards something. And so it just forces mass times acceleration. So, weight is the everyday term for the force due to gravity. So, weight, force due to gravity, is mass times the acceleration of gravity, which we usually just write as a lowercase g, because it's gravity. But gravity is an acceleration. It is an acceleration. It is not a force. There's a force because there is a force due to a gravitational field. But the actual acceleration gravity is actually an acceleration near Earth's surface. And the number we're going to use for that is 10. The number that you'll see in a lot of papers and books and things is 9.8 or 9.81. But for us, we're going to mostly use 10 because it makes the math easy. Okay, now, there is one other force that gets an actual formula. The force of static friction. And it has a maximum value of force friction equals mu times force normal. This is the maximum amount. So here's another cute little Greek letter. So these are the only 3 formulas we actually have for essentially this whole unit. Just 3 of them. Force of friction is mu, which looks sort of like a U with tails, or it looks like kind of a funky M. Somebody's cute little script M that doesn't quite match. And then times force normal. The coefficient of friction we'll talk about here in just a few minutes. But those are the only things, the only 3 formulas we have. We have weight, we have net force formula, and we have friction formula. Everything else we have to figure out from the words in the problem. don't need the la 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 that much. All right. Waiting for people to finish copying, then we'll work some problems. We'll start with the easy ones and work up to the harder ones. We were supposed to have a fun thing on Friday. We can't do pep rallies, but we were all going to go out to the football stadium and do something fun that we can do. And then hurricane, whatever the crap is coming through. So things like that. You know, kind of a weird time. Okay. So, one of the problems that's in our textbook that makes me giggle, because not in your textbook, in my other physics textbook, is this problem. The mug and root beer is 0.75 kilograms. Find the following. Number 1, weight of the mug. 2, normal force from the table. And number 3, acceleration of the mug. So I'm going to wait right there for you because I know you write faster. I'm going to drink a little tea. And as far as we know, if you're a junior, the way we took the ACT for the seniors will be the same thing we do for the juniors in March. So we'll do 11 or 12 kids in a room. So we'll use, and everybody else will stay home that day. Usually we send the seniors that day on a field trip to college days or job shadowing or that kind of thing. So, whoops. All right, you guys got to tell me if you can't see all the words. I'm sorry. Our physics book for my other kids also has a book about bullets and shooting at students and stuff, and it's like, that question was kind of inappropriate. It was like supposed to be funny, and it wasn't funny at all, but, you know. Is this a tropical storm or a hurricane? Does anybody know that's coming? Okay. I haven't been watching the news. That means we'll also have a fire drill next week because you have to have one every month. And next week is the end of September. Did we already do one in September? Seems like we did after Labor Day. If we have, then we won't have to do another one. But you have to do one a month. You have to do 2 in August and 1 a month the rest of the time. Sometimes we do them on days when y'all aren't here, so it's all the teachers go out. It's kind of weird also. Okay, so what we've got to do here, and we don't have to do the things I'm fixing to do, but it's going to help, and it'll help with the harder problems. So we're going to do it on the easy problems to show you the process, and then as the problems get harder, it'll get a better way to attack them. So what forces, we have these things called free body diagrams. And what is the free body diagram for the mug? What forces are acting on the mug? So I put my dot as my mug. What forces would be acting on it? What force do we have on everything near Earth? You have a force due to gravity. Everywhere near Earth, even all the way out to the moon, there's a force due to gravity. I know they say you're weightless in space. We'll have to talk about that. That doesn't mean that you don't have any gravitational force. So we have gravity. And then the name of the force that pushes up from the ground that keeps me from sinking into the ground or the mug sliding directly into the table, what do we call that one? It's probably the other one in the problem. Force normal from the table. And then we have a force applied that's from the bartender. So when I draw this free body diagram, I would draw it like this. Force normal, force gravity, force applied. So I can see my forces. I'm writing all the words out so you know what the subscripts mean, what the abbreviations are. So where is our unbalanced force? Which one of the forces is the unbalanced amount? The applied force would be the unbalanced amount. So let's start with that one. So right here, we've got 1, 2, and 3. I'm going to start here. We know that the net force is equal to mass times acceleration. This is Newton's second law. N2L, Newton's second law. So our force, they tell me in the problem, was 10 newtons. This number is 10 newtons. And my mass of my mug was 0.75 kilograms. And acceleration, I don't know. Now, we get tired of writing. Let me come back over here real quick. We get tired of writing kilograms times meters over second squared every time we have a force. It's always going to be that because you always have a mass and you always have an acceleration. So we got tired of writing that all the time. So people decided to honor Isaac Newton by making this unit called a Newton. That way we only have to write one letter, N. So when it says over here 10N, I could have just as easily written 10 kilogram meters per second squared, and that would be the same thing. Because a Newton and a kilogram meter per second squared, same thing. So, to do this problem, I'm going to divide both sides by 0.75. And the kilograms will cancel out. And I will get acceleration in meters per second squared. So 40 divided by 3 would be 13.3, repeating. So my acceleration would be 13.3 meters per second squared. I'm hoping I did that right in my head, but given the day I've had on the smartness, my smartness level is pretty small today. So we're going to double check that. Oh yes, I got that one right. Okay. So, any questions about how I got that piece? The unbalanced amount would be called the net force. Just like if you get paid at your job, you get a gross pay statement and a net pay statement. The net pay is the amount you get to take home. The gross pay is what you got paid. So the difference is they have to take out what? Taxes, Medicare, health insurance, whatever comes out of your paycheck. And so the number that's at the top of your paycheck is not the one you come home with. And it's always sad, right? Because in my case, it's about $1,000 short a month. It's like, ooh, I just lost 25% of my salary. but I want health insurance and dental insurance and retirement money and, stuff like that. So here we go. All right, now, my other two questions, we found the acceleration. That was actually question number 3. So let's back up to the other two questions. The other two questions are we want to find the weight of the mug and the normal force from the table. So I'm going to go over to the weight from the mug, which is question number 1. And I'm going to go weight is force due to gravity. So force due to gravity is mass times 10. So 0.75 times 10. So the force due to gravity is 7.5 newtons. So now on my picture, I know this one is 7.5 newtons. Weight is the force due to gravity. And now, last but not least, how are we going to find the normal force? See, we don't have a formula for the normal force. You don't get a formula for that, so you have to use your picture to figure that out. What would our normal force be? Well, if he takes a mug and he slides it across the counter, I don't expect the mug to shoot straight up in the air, right? I also don't think it's going to sink straight down into the bar. It's not accelerating up and down, it's just sliding horizontally. So for me, that means that the force of gravity must be balanced by the force normal. So we know this is going to be 7.5 newtons. Here's how we show that. Add up all your forces, in this case, vertically. We have to keep vertical things and horizontal things separate. We'll spend more time on that as we go. So, mass times acceleration. Well, force normal points up, force gravity points down, and our mug does not accelerate up or down. So acceleration is 0. I don't accelerate up or down. If I don't accelerate up or down, what does that mean about my two forces? If I add force gravity to both sides, I get force normal equals force gravity, so it also is 0.75 newtons. I'm going to get over here and pull up that file. We'll do one off our sheet.